Good evening, everyone. Hope you're having a fantastic weekend. Of course, I would start my stream and find out my microphone is at a stupid level. Welcome back, hey? Welcome back, everyone. I'll admit I'm quite nervous. It's been a while since I've done this, and towards the end of when I used to stream, I'd get quite good when I was going live. I'd hit the go live button and be pretty not nervous about it, but I'll admit tonight I'm pretty nervous. And already fiddling with my microphone stand, probably as a nervous habit. But look, hopefully I haven't screwed up any of my OBS config. Hopefully I haven't screwed up any of my environment. Hopefully I don't leak anything silly on stream, because it's been a while since I streamed. And I used to have a pre-go live checklist that I'd go through top to bottom, which would avoid me leaking things onto the screen that I didn't want shown. So fingers crossed, everything is still airtight. Fingers crossed the changes to my system I've made over the last 12 months don't lead to anything embarrassing. But thank you everyone, first of all, for your patience while I took some time off. As many of you probably know, I upped and moved city. So I moved interstate within Australia. I now live in sunny, well, sometimes sunny, sometimes rainy, sometimes windy Melbourne, sometimes all within the same 10-minute window. And I took a new job this last 12 months, and I just wanted kind of some time off to focus on that. And I originally, as many of you probably know, I took some time off to do the move and thought, oh, I'll give it a few weeks, maybe a few months, and I'll be back. And as these things go, once you kind of stop streaming or doing a lot of hobbies and stuff, weeks become months, months become almost 1 year. I think I'm about 5 days short to the year of taking a year off. So I'm back within the year, back within 12 months, which is hopefully somewhat of a win. But yeah, I mean, I, from week to week, month to month, kept saying I should stream again soon, I should do something again soon. One of the things I was really nervous about was recommitting to a schedule. So what I'm doing is to ease my transition back to this world. I'm not committing to a schedule. So I'll be streaming when and if I get a chance. Sometimes they'll be weeks apart. Sometimes, I mean, they could be months apart. But yeah, I kind of had to realize that I wasn't going to be ready to commit to a schedule again anytime soon, just due to time pressures, pressures of life, new priorities I have take up a lot of my time. And if I was going to kind of wait until the time was right to get back to what I used to do, which was actually, I think, twice per week. I think it went down to once per week towards the end. But if I was going to wait around until... Just trying to fix the levels in my microphone. Headphones. Testing. That's better. If I was going to sit around and wait until kind of things were right and life was right for me to start doing weekly streams again, it wasn't going to happen. So them's the breaks. I'm back. I'll be back from time to time. I just don't know when that time's going to be. So thanks for all your... hey, Mongo, really good to have you here, dude. Thanks everyone for tuning in. This was very impromptu. I kind of got to half an hour ago, and I carved some time out tonight to just kind of reconfigure the whole streaming environment. And I kind of got it tweaked, and I was just like, you know what, fuck it, let's give it a go. So thank you all for tuning in on very, very short notice. It's really good to have you all here. I'm recording, I'm streaming. Everyone, please let me know if the audio is off, if the video is off, if there's any problems. Do it live, that is right, Jardeth. Elsie Blades, Beards. First time catching you live. Thank you for tuning in. Really good to have you here. Justinitus, yes, you met me GG at a birthday thing in October last year. Dude, so good to have you here. We should head out to GG again sometime. That was a good night. I really enjoyed that. Zara, see me go, fuck it, yes. If you haven't realised, I don't cuss a lot, but this stream, if you've got little kiddies around, maybe the headphones, if there's any sensitive earballs in the area. I think someone asked if I've got a beer going. No, I don't have a beer. I've only got really heavy beers in the fridge. I've been drinking these really strong IPAs lately. I've already had one and don't really want to be having another one on stream. Things might get sloppy. All right, how about we just get into it, hey? Enough waffling on. Thank you everyone for tuning back in. Really, really good to have you here. I hope you enjoy things. And again, yeah, if there's any problems with audio, video, whatever it is, please let me know. I'm going to be going tonight through at least a couple of levels of the ROP Emporium. Now, ROP Emporium is something that I had on my radar towards the end of my previous streaming career, and was like, hey, we should get around to doing ROP Emporium sometime. I have not looked at any of these challenges, so I'm going to them completely blind. I've had a few people since then kind of hear that I was considering doing ROP Emporium, go, fuck yeah, let's do ROP Emporium. So let's get into it, eh? So the first one here, oh yeah, and for anyone who's tuning in for the first time, tonight we're doing some hacking to computers. So this is binary exploitation that we're going to be diving into, which is a unfortunately dying art because computers are getting harder to hack when it comes to binary stuff. All these screwy modern exploit mitigations are coming in, which is ruining the fun for all the new budding hackers. But I mean, they're going to live on in CTFs for a long time to come, I think. So we're going to be doing computer hacking tonight. Hopefully you enjoy this. If it's kind of not your cup of tea, that's cool. If it is your cup of tea, I hope you enjoy it. So I'm guessing with these ROP Emporium challenges, we go maybe left to right, top to bottom. I don't know, but I think red to win, return here to win. This sounds like a nice starter challenge to me. So we'll hit up ret to win. Locate a method within the binary that you want to call and do so by overwriting a save return pointer on the stack. Click below to download the binary. Do we want to go 32 or 60? Whoop. Twitch dashboard is telling me that maybe I'm lagging a bit. Am I lagging anyone? I just had Twitch dashboard kind of go a bit funky on me, so please let me know if anything goes screwy. No dropped frames. Maybe it's just my end. Running fine for me. Fantastic. Thanks to Wizzy. No lag. Looks fine. Alright, thanks everyone. Men's doing 32 and 64. Mongo votes 64. Yeah, let's just go straight to 64. I mean, ret to win, I think is going to make almost bugger all difference if we go 64 or 32. With ROP, when we get to the trickier stuff, 64 is going to be more painful than 32 for reasons that we'll get into when real ROPing comes to light. But Mongo's thrown down the gauntlet. Let's do 64. If there's any benefit later on to kind of doing 32 first, maybe we'll figure it out as we go. But I think ret to win is going to be pretty simple to start with, just plain old 32 with 64. ROP Emporium. Alright, so we get a zip file. We'll unzip ret to win. Okay, so we get a flag. That was really easy. The first one, ret to win, we've solved it. Here's the flag. So what's next on the list? Bad. I'm just kidding. So they're shipping flag.txt with the binary, meaning that, I mean, normally when you look at these kind of pwnables, a lot of the time you're expected to shell them. But I'm guessing with ret to win, there's probably a function in there, like a little fancy, handy place to land that they'll probably put in there that just reads flag.txt for you, I'm guessing. What happens if we just run ret to win? Ret to win by ROP Emporium, 64 bits. For my first trick, I'll attempt to fit 50 bytes of user input into 32 bytes of stack buffer. What could go wrong? May I have your input, please? And don't worry about null bytes where user f gets. Coolio, so A, B, C, D, and it exits. Let's fire up Vim. Let's get rid of ret to win.zip, and let's just move ret to win to ret to win 64, so we can keep track of what's going on. So let's create pwn ret to win 64.py, and let's kick off a Python 2 pwn tools script. So what we want to do is we want to kick off a tube, and that tube is going to be pwn.process ret to win 64, I think it was called, and we'll go t.interactive. ROP Emporium, and we'll chmod that Python script so it's executable, and we'll run that Python script. Can't open file 2. What have I done? Aha. I was stupid. I don't know why I typed that. Nerves, I tell you. Shebang use bin end for Python 2. What was I thinking? All right, so what we've got is we've got a small pwn script here. By the way, normal things apply. Cheater. Yes, at Wolf, haven't we all? If you need my attention in chat, actually, you know what? Maybe I've screwed the highlights, because I did change my Twitch name tonight to Justin Stephen, because for years and years, I reckon I signed up on Justin.tv years ago as Justin Stephen, or maybe they just put a ban on anyone's name being Justin on Justin Stephen on Justin TV. I don't know, but I could never register on Twitch.tv Justin Stephen. But just tonight, I was like, I'll give it a go again. I wonder if I can actually basically rename myself to Justin Stephen, and I can. So the Justin Stephen is no more. Justin Stephen is the way to go. Look, can I get a favor? Can someone please use my name, Justin or Justin Stephen, and let's see if I get a little ding in my IRC client, because I've got a feeling that maybe it's only recognizing the Justin Stephen, which would be unfortunate if that's the case, and I don't really want to dive into my config file on stream with it. We got dings. Okay, it's a Justin Stephen test ping test. Okay, so looks like the word Justin Stephen, or at least at Justin Stephen, is getting my attention. So if I've done something silly, or you've got anything to say, or you've got a question to ask, Mongo, I wasn't unfocused, so I don't know if the Justin Stephen's pinging me, but no one really should be calling me the Justin Stephen anyway. If you need my attention in chat, please use my name. If you've got any kind of queries, at least while Mongo's around, I reckon Mongo, I'm voluntolding you that you'll be able to help people out if they kind of have any queries, questions, concerns. If you want to, you can also use my name, and I can help you out with any queries. But yeah, Mongo and I will have you in good hands tonight if you're not following something that's going on. If you haven't done any exploitation stuff before, some of these things will be fairly obtuse, but just kind of stick around and hopefully some of it at least will make sense. Binary exploitation is one of those things that you just get a feel for after a while. It's kind of like the Matrix. After a while, you don't even see the code, you just see blonde, brunette, and redhead. So let's go to this tube. Let's send line, and we'll send buff down the line. And what's buff going to be? Buff equals empty string. Buff plus equals A times 1024. Send a kilobyte of A's down the wire. Yeah, Barney, Mongo's your man for Facebook hacking. He's all about that for sure. All right, so if we run what we've got now, we'll run this pwn script. And we got, yep, sigsegv. We've got a seg fault in the ret2win64 process. So that means we've done something naughty to it, and it has been unable to finish executing. So now, as I normally do, let's attach GDB from pwn. Pwn is super nice. We can actually attach GDB straight from our script. So we'll go GDB CMD equals, let's make it, this is the pattern I've been using in my CTFs lately. So GDB CMD will be a list of commands that GDB will be told to execute upon attaching. And we've got pwn.gdb.attach to the tube. I can never remember this syntax. Python 2 from pwn import star help GDB. Is it GDB exec or something like that? GDB script, one word. GDB script equals, we'll get a new line and we'll join GDB CMD with new line. So that way we can kind of add to our GDB CMD list of commands, and GDB will automatically have it shoved down its gullet when pwn pops GDB. So if we redo that pwn ret2win 64, you'll see that pwn is super handy. It actually pops GDB for us, and we can see that the binary itself, we've been given the red $sign because this t.interactive is giving us an opportunity to interact with the binary. But down here we can see GDB is quite sad about something, and it's picked up a sigsegv. So what have we got in GDB? So at pwnme plus 91, there's a function pwnme obviously. There's a ret happening, and on the stack we've got a bunch of A's. So we're trying to return to an address that is not legal. And I had someone recently kind of say to me, yeah, my crash looks weird. I don't have RIP control. I don't know why this is, but GDB, when you're debugging a 64-bit binary, in my experience, Looks like it hasn't given you RIP control because RIP still points at the ret, but obviously at the top of the stack we've got a bunch of A's. So you do have RIP control, but you don't get that classic GDB 32-bit experience where RIP actually comes up as 41414141. 41414141. Any chance I can increase font size a tad at all? It'll take a few minutes, but I probably can. Yes, I have been playing with my environment tonight, trying to get the most out of my real internet connection. So you know what? Let's take a quick break. I could use a little breather because, you know, I'm hyperventilating a little bit here behind the scenes. 64-bit, you crash at the ret rather than getting RIP AAAA because it's odd. Okay, so it's an alignment issue. Interesting. Jardeth is saying it's not too bad if you full screen it. Yeah, but I mean, people don't really want to be sitting there watching only me. I'm sure they've got real interneting to do with me on in the background. So look, let's take a quick 5-minute break. I'm going to do my best to try and up this font size without killing the stream. Yeah, let's do that. Give me 5 minutes. We'll be back in 5 and we'll see if we can get this fixed up. Alright, we're back. Can peeps let me know, is this at least a little bit better? The reason why I had to go off stream to do that, by the way. Oh, it's gotten dark. Is it just me or has it gotten a bit darker? Let me turn this light on as well. The reason I had to go off stream for that was because I had to edit some config files that I don't want shown on the stream. Come on. There we go. Hopefully that lights my beautiful face up at least a little bit better. Much better. Awesome. Thank you, Barney. Atwolf agrees. Alright, thank you, peeps. Yeah, let me know about those things as time goes on as well. I have rejigged my environment quite a bit, so if anything's not quite what you're looking for, please let me know. One of our consultants will be more than happy to make you happy, if you know what I mean. Alright, let's get back to what we were doing. Nope, don't need your chromium, not right now. What are we doing? ROP Emporium. So this is where we were a second ago, right? And Mongo was saying that because for one isn't aligned. 1, 2, 3, 4, 5, 6, 7. What? No, that should be fine. Looks like maybe we only just managed to actually. Oh no, I think no, yeah, the challenge. We should actually probably be adults and actually look at this binary. I was thinking that, oh gee, a 1024 was lucky, you know, we only just managed to smash that safe return pointer, but not the case. I think they're not letting us actually get our full 1024 bytes onto the stack. By the way, for anyone who didn't hear the news, IDA has released a new free version that does, I'm led to believe, 64 and 32-bit. And I think it's version 7.0, so it's a big bump from the crusty old 5.0 or whatever it was that IDA used to have for free. But it's a huge benefit that it does 32 and 64. Still only does Intel, I believe. Like, so you're not going to be able to use it for ARM. Won't be able to use it for Mac OS binaries. But hey, if you're getting into the binary game, there's probably never been a better time, with Binary Ninja being as good, I'm led to believe. I've actually got a copy of Binary Ninja now. Thank you to the kind folk at SecTalks Melbourne for a CTF prize. But with the price and the rave reviews that Binge is getting, with there being a free version of IDA that does 32 and 64, I believe, there's never been a cheaper time to get into opponents and bins. So put that in your pipe and smoke it, peeps. Alright, so we've got some stuff getting putzed, and then we're calling pwnme. So pwnme, we've got stood in being moved to RDX. We've got an fgets happening of OX32 bytes. Alright, so that we didn't, you know, even though we tried to shove 1024 bytes of A's down the gullet of this thing, we actually only got OX32 of them into this offset here, RBP plus S, which is a character buffer of OX20 bytes or thereabouts. Alignment pending and other gaps on the stack pending. So here's our bug. We're fgetsing too much data into this poor S buffer, and then this ret is having us return to what is currently an illegal address. So Mongo, do you suppose that perhaps if we send B's, because, you know, B's are more alignful than A's, and what we've got OX32, OX32 B's, I think we'll actually only get OX31 of them, followed by a null byte in. Maybe? Is that fgets? Does fgets do n-1 chars? Nah, we'll send OX32, that's safer. If we send a more alignful buffer, do we perhaps get rip control? No, okay, so yeah, I'm not 100%. Maybe I've got the wrong idea when Mongo says because A's aren't alignful. Maybe B is also not alignful. But yeah, we don't have what looks to be rip control in the kind of traditional GDB view, but we do have a ret occurring with a bunch of B's at the top of the stack, which is just as good as rip control. So now this binary is called ret to win, and so we're in the pwnme function when we get this rip control at the time of the return. So ret to win indicates that there's a winning function that maybe we want to cause the ret to go to. The function ret to win looks pretty good to me. If we have a look at what ret to win does, it printfs the string "thank you, here's your flag," and then it moves the string bincat flag.text into EDI and then calls system. So it's just going to run bincat flag.text for us. Not bad at all. So this is a dynamically linked binary, and we've got a pointer to system. So this, I believe, would be maybe shellable. I'm going to say it's definitely shellable. I'm confident we could probably shell this if we put our minds and our hearts to it, but that's not what this challenge is calling for. And the future challenges are the ones that want us to shell them. Maybe once we've shelled those, we can come back and shell this one. But for the time being, all we really want to do is cause a ret to this address to occur. And we should get our flag printed out. Now, key question. Mongo may have been misremembering the alignment thing. Yeah, no dramas. One of those mysteries of the world, I guess. In Pymie, the F gets in OX32, but the destination is OX20. That is on the money. I'm just curious now. Man, F gets. Is F gets one of those things it gets? Yeah, so it reads in at most one less than size characters from stream and stores them in the buffer pointed to by S. So I think we're only getting OX31 into our buffer. Neither here nor there, we've got control over the full width of RIP. So what I wanted to do was a cheeky old check sec. Yeah, so we've got NX is on and PIE is off. So this binary is not ASLR'd, so we can just go and drop a pointer to ret to win straight over the top of our SRP overwrite, and we're off to the races. So now we've got a pointer to ret to win. That's there. Now, of course, we need to find out the offset to our save return pointer overwrite. So instead of sending OX32Bs down the wire, we'll do pwn.cyclic with n being equal to 8, because we want every 8 characters or every 8 bytes of the pattern generated by pwn.cyclic to be unique. Switch ROP Emporium and run that pwn. Now we should. I've missed this playlist too. That is really unfortunate. That is purely because the letter G comes after the letter F. That is a shame that was the pattern that ends up in the save return pointer. Let me just show you what's going on there before anyone cries foul. If we import pwn and do pwn.cyclic OX32 with n equal to 8. So here's the string that we shoved down the wire. And unfortunately, that there was the exact slice of that cyclic pattern that got put into the save return pointer slot. So that is an unfortunate thing. What a cracker start to streaming again, hey? So instead of doing pwn.cyclic OX32, we'll do, comment that out, buff plus equals, do a times pwn.cyclic find. We want to find that substring within the cyclic generator for n being equal to 8. So this here, cyclic find, will return the number of bytes into this string here that substring appeared. And so what we're going to do is we're just going to fill that up with A's, and then we're going to do buff plus equals B times 8, and we should get RIP being equal to, well, effectively RIP being equal to OX 42424242424242. That's the wonderful thing about 64-bit. You get to say really big pointers when you're reading stuff out. So we'll fire that one off, and we get a segfault. And at the time of the ret, yeah, we got a bunch of B's at the top of the stack there. So that demonstrates really nice tight RIP control. We can put exactly 8 B's into it. So instead of 8 B's, we'll do buff plus equals pwn.p64. I bet all you jokes are having a giggle over here. It amuses me far much more than it should. The mod habit's coming out. Yeah, lols. Yeah. Laugh it up. Laugh it up. We want to pack a 64-bit pointer to our ret2win pointer, to our ret2win function, I should say, and then we're going to send that down the gullet of the process, and we should get a flag. Thank you. Here's your flag. ROP Emporium, a placeholder 32-byte flag, and then looks like the process exited normally, because system. How does system work? Man, system, does it replace? No, it does a fork. It creates a child process that executes the shell commands. Cool. We managed to avoid a crash happening in the ROP Emporium process itself, I think. Or maybe it just got disguised by GDB getting really excited about the dash happening and the cat happening, and maybe our original process went down in flames behind the scenes somewhere. Either which way, there's our exploit for ret2win. We've got a payload that causes flag to be read for us. The top bits of the pointer are set, and it's just an invalid pointer. Can only use the 48 bits probably. Yeah, cheers Mongo. It's not a kernel pointer. Is it a kernel pointer? Might that be why GDB... I mean, but Mongo, my thing is like 32-bit processors in GDB. Like GDB will very happily step into that ret and then shoot itself in the foot with rip equal to a bunch of A's. Invalid pointer, top bits. Is it a kernel pointer or something? Does kernel land take up a lot of the 64-bit space? 5 A's and we'll get a rip. Let's give it a go really quickly. See if we can get GDB to emulate what we're used to when we crash a 32-bit process. Buff plus equals pwn.p64 ox 1. So this is just going to be 4 A's. Does Mongo want 4 or 5 A's? 5 A's. Let's do 5 A's. Pwn.p64, this will give us a pointer with the top bytes being 0, which may give us the old faithful behavior. Yeah, there it is. Rips a whole bunch of A's. What if simply the top byte of the pointer is null? 1 for 1. I think that's all but the top byte, isn't it? Yeah, so it's not happy with 2, 3, 4, 5, 6, 7. Not because there's a new line there. Here's a new line. Oh no, there'll be a leading null. That's a proper pointer width. Yeah, so 7 A's, it's not happy to kind of give us that classic rip control, or the appearance, the classic appearance of rip control. Let's drop an A. Yeah, okay, so 6 A's will give us that kind of Coke classic behavior. Any more than that, and GDB doesn't want to step into that ret. Just curious. Only 48 bits. Oh, not the whole 64-bit address space is usable, only 48 bits. So the top part of the address has to be all F's for kernel, or all zeros for user mode. Okay, so Mongo, is there a really big hole between the kernel and the user mode address spaces? Like the kernel kind of goes from the top down and user mode goes from the bottom up, and there's a hole in the middle. What if we go FF? Yeah, wasn't happy with that. Yeah, okay. Maybe GDB is never really happy to step into a ret to a kernel pointer anyway. I mean, I'm not expecting it to actually execute stuff out of the kernel, unless you're into that Meltdown Inspector, but I think that might be that might be somewhat of at least how Meltdown Inspector worked. But yeah, looks like there's only 48 bits of user land. Top part of the address has to be all left ordered. Okay, yep, cool. I think we can move on from that. I think we've done that one to death. Cool, I'm going to take a quick 2-minute breather. I'm going to just turn the aircon up a bit because I am really quite warm here, and I'll be back in a second.
I'm running away from this pain. I'm trying to find a new way where the sun's shining down on my face. I'm running away. You're in a toxic relationship. Time to be free.
Alright, and we're back. By the way, I've got a hat in hand ask of y'all. As you may have heard, YouTube is going and kicking out all the small fish from their YouTube partner program. Anyone with less than 1,000 subscribers and less than 4,000 hours of view time in the last year loses their ad revenue money. And I really need that. I'm up to like $10 so far, and I'm really looking forward to cashing that out once it gets to 100 and buying some ice creams. So I only need about 700 and change hours more view time in the next 2 weeks to get me over the line, and about 80 more subscribers. So tell your friends, have some movie marathons, and watch me being stupid for like, I don't know, 700 hours in the next 2 weeks. That'd be awesome. How about we, oh, I don't care if I lose that partnership program, by the way. But seriously, if you've got friends who don't know about it, let them know about my YouTube channel. How about we go on to the next challenge, hey? ROP Emporium. I was going to try and shell this one that we're working on now, but I want to save that because I reckon some of these challenges, as we work through them, we'll be dealing more and more with some of the techniques that I would have used to shell this. So I think we should stick with it. Badchars. Learn to deal with badchars, characters that will not make it into process memory intact, or will cause other issues such as premature chain termination. Let's give 64-bit badchars a spin. By the way, I'm intentionally avoiding reading these because I think there's some spoilers and stuff in those. If you're looking for spoilers so you can feel cleverer than me while I battle through it, go check out the ROP Emporium site. It'll give you some hints as to what I'm working on. So we'll move the badchars challenge into Twitch ROP Emporium. Tear all this down. And unzip. We don't need all that IDA garbage anymore. Close this. We don't need that database. We did nothing interesting. We need to unzip badchars. Replace the flag. Nah, we'll just use the same classic flag we've been seeing so far. And we've got a file called badchars. We'll move badchars to badchars 64 to disambiguate any 32-bit version we may exploit in the future. So if we run that file, badchars 64, it's giving us some hints. Badchars are BIC / FN and S. I hope it's not telling me that badchars include left angle bracket, right angle bracket, E, C, A, P. That's getting a bit much. I'm just kidding. It's bound to be space, right? Bound to be. That'd be a really sweet CTF troll though, to use this to actually indicate each individual letter in that sequence as being badchars or something to do with a challenge. I'm gonna put that one in the back pocket for when I want to make some enemies. All right, so let's just be lazy. Let's copy our pwn ret to win across to pwn badchars 64.py, and we'll fix up the path to the binary. Badchars 64. We'll leave the pwn GDB attached. That looks fine. We'll get rid of all this and just go back to the t.interactive. So this will be a nice little skeleton that will probably take through the rest of the challenges. So you're not sitting there while I type it up each time. So we'll run pwn badchars. And there we go. We've got a little interactive prompt here. Type some stuff, and we've got GDB. Send a bunch of A's, and everything tears down nicely. So again, t.sendLine buff. And we'll do buff equals empty string, buff plus equals A times 1024. Good old kilobyte of A's. So we'll run that. And because A was not volunteered by the binary to us as being a badchar, we successfully get a save return pointer override. And rip's pointing to a ret, and stack is full of A's. Lots of A's. So now what I think I will do is badchars equals, let's just set up a list of what they're telling us. Actually, you know what? We should probably confirm what they're telling us and check to see if we can identify the code that is enforcing this badchars behavior. Alright, so we've got a call to pwn me. Here we're being told about the badchars. We've got our fgets. This time we can supply up to OX 200 characters to be put into S, which is of around about OX 28 bytes in length before bad stuff starts to happen. They'll do an nstrlen on the string. We're moving racks to RDI. And then we're getting the strlen and racks, which is being returned by nstrlen from racks into n. So this is our input len. S is our input. And then our input len is being loaded up into RDX. Our input's being loaded into racks, RDX to RSI, racks to RDI. So an important thing to note is that on 64-bit, function calls are parameterized using registers. I've got a handy dandy. Let me just go and quickly grab a copy of my x64 calling convention for Unix, and I'll put it here. So So the first 6 integer or pointer arguments to functions under Unix in 64-bit are passed in the following order: RDI, RSI, RDX, RCX, R8, and R9. So normally you'll kind of see 3 or 4 parameters to a function, and RDI, RSI, RDX, RCX are what we parameterize function calls with. So RDI is coming from racks, and racks is coming from, so racks, the first argument to check bad chars is a pointer to our input. The second argument, RSI, is coming from RDX, which is our input length. So there's a function called check bad chars, which if I was a betting man, I'd say that that's where it's checking to make sure we haven't used any bad characters. If I was a betting man, I would say that these hex values here are the ASCII characters, or the ASCII values for the characters, like 2F I know is /. I know the challenge was telling us that / is a bad char. 20 is our space. So this here looks to be the list of our bad characters, I dare say. So if we just go and copy that there. So 62 is our first bad character. Let's just go and check to see what all these are. So here's our bad characters. In fact, we can just go and drop this straight into our code. It may be useful to refer to later on. You know what? That's what I was already doing. I'm a clever cookie, aren't I? So bad chars. Here's our list of bad characters. In fact, we should be mapping the char function over the top of that, shouldn't we? So they're not simply integer values, but they're actual. So let's just go. Bad equals that. So is it map char over bad? Yeah, there you go. So if we just map the char function over this bad list, we get the actual literal characters. And it looks like it's pretty bang on to what they were saying it was. I wouldn't think that this challenge would be lying. BIC/space FNS. BIC/space FNS. Great. So that is our list of bad characters right there. So I'll map char over the top of that list there. So we know what our bad characters are. Oh, we need to find out what our offset to actually getting the save return pointer overwrite is. Instead of 1024 A's, let's go pwn.cyclic of length 1024, where n is equal to 8, and cross our fingers that we don't get an inappropriate subset of that cyclic pattern being our indicator as to what our offset is this time. Let's run this and get our offset. So the ret's happening at the time that this pointer is at the top of the stack, which looks like it's gaha. So we'll, nah, it's not. It's a bunch of A's and then EB, whatever EB is. So instead of that, we'll have enough A's. Actually, you know what? Let's be adults about this. Offset to the save return pointer equals pwn.cyclic find. We'll find that pointer in a cyclic pattern of n being 8 to have ensured that every 8 characters in our cyclic pattern was unique. Instead of this here, we'll just do enough A's to get us to that save return pointer overwrite. So we'll do A times offset SRP minus the length of buffs so far, which is 0, but this pattern here is one that allows us to really conveniently put stuff there if we ever found the need to, without destroying our alignment and our careful use of offsets discovered so far. Buff plus equals B times 8. So hopefully at this stage we get a crash on a ret with a whole bunch of B's being at the top of the stack. Nah. What happened? Oh, is it because... Is it because lowercase b and uppercase b are bad characters? No. No. Our cyclic... Yeah, our... Let's back up. Let's back up. Pwn.cyclic of 1024 with n being equal to 8. This has got things like b in it, which we know to be a bad character. Now, we actually didn't dig into and reverse engineer this function to see what it does with a bad character. I mean, we still got a crash when we fed down the gullet of this binary, this string here, including things like lowercase b, the bad char, lowercase b. So maybe it corrupted them. What is char oxeb? Yeah, this EB here, that's indicative of corruption. Yeah, cool. So this function here probably in some way mangles any bad char that we try to use. Is there any like XORing or anything going on in here? Yeah, I would say that the use of a bad char inside pwn.cyclic screwed us there. I'll comment that out for now. We'll comment this as well. Let's go buff plus equals b times 1024. We know b is lowercase b is a bad character. Let's run this. Yeah, so we got a crash with a whole bunch of oxeb being on the stack. Lowercase b is ox62, not oxeb. So the check badchars, is it check badchars function? Yeah, check badchars function has gone and corrupted any time we've tried to use one of those bad characters. So at this stage, we've got two options, right? We could try and find out in what way, it looks like it's a deterministic way in which the program chooses to corrupt any use of a bad character that we attempt to make. We could do that, or we could try not to use any of those bad characters. Now that might be tricky. We may find that we want to use a function pointer later on that they have intentionally introduced a bad character that would otherwise be required for the use of that function pointer. For the time being, let's try to avoid using bad characters. If we need to, we'll reverse engineer this function or just dynamically try and guess and check what is the way in which it's corrupting our use of bad characters, and we can then compensate for it when we produce strings. Firefart says you can provide a custom alphabet to pwn.cyclic. Yes, you can. Thank you, Firefart. That was going to be what I was doing. Thank you for the heads up. Have I missed anything? Hope you make it for the ice creams. In this weather, yay for ice cream. Yes, absolutely. I had a cheeky ice cream tonight, actually. Press R in IDA on the hex value. It's the same key in Binger. That's see, that's knowing how to use your tools. That's not what I'm known for. Well played. Well played, Meepsaw. Thank you for the heads up on that. Yeah, so we're going to go ahead with Firefart's suggestion to actually provide a custom alphabet to pwn.cyclic. Menz wants me to link the param order again. There it is. Can I drop this like elegantly into Twitch chat, or probably not? I don't want to junk up my chat with that. Menz, you've got like 5 seconds to note that down. 4, 3, 2, 1. Yeah, let's go exit this because I screwed up. From pwn import star. Let's consult the documentation like grown-ups. We'll go help cyclic. and this is going to tell us how to actually pass bad chars into cyclic, so that it avoids the use of anything we're banned from doing. So we can provide an alphabet to cyclic, or we can use the actual global context of our exploit to set it. So we can provide an alphabet. Can we provide bad chars? You know, a blacklist, or no, I think we have to provide like a whitelist basically. So we actually provide the alphabet to cyclic so that it only uses things that we know to be safe. So this is just going to be a quick hack. What we'll do is good chars equals, we have to give it as a list or a string, yeah. A, B, C, D, E, F, G, H, I. That should be enough characters for the purpose of pwn.cyclic. Some good chars equals A, B, C, D, E, F, G, H, I. Unless lowercase I and uppercase I are banned. So we'll get rid of I just in case. We'll get rid of C just in case. Get rid of B just in case. J, K, L. Flesh it back out again. So here's some good characters that we'll use to pass to pwn.cyclic to generate our cyclic pattern. Alphabet equals some good chars. Firefart, yeah, custom alphabet. Okay, cool. So you weren't saying you can provide a list of bad chars, you can provide a custom alphabet. Men's has noted it down. Well played. Get rid of those B's, and we'll just send our 1024 length cyclic pattern down the gullet. Alright. 1, 2, 3, 4, 5, 6, 7, 8. We'll slice off the first 8 characters at the top of the stack, because that's effectively what this ret is trying to return to as a pointer. So offset SRP equals those 8 characters. So for pwn.cyclic find, we need to remind cyclic find that we generated our cyclic pattern using a restricted custom alphabet. We should get that offset SRP calculated nicely. Let's try again. Buff plus equals A times offset SRP. No, we want to do offset SRP minus the length of buff so far, just in case we need flexibility in the future. Buff plus equals, I'm going to put in, I'm just going to copy this quickly for my own reference above our badchars definition. So we've got B and C being illegal, but is that lowercase and uppercase? I don't know. I could, read the disassembly in IDA to find out, or we could just experiment, guess and check. Alright, let's assume that it is bad, and we'll prove that we've got nice tight rip control. And then I want to see if capital B gets corrupted by our check good chars function. We'll run this work in progress exploit, and there we go. We've got a bunch of D's being returned to as a pointer. Nice. On our way. What if we swap this out for capital B? I mean, we know that lowercase b, we saw lowercase b was getting corrupted before. Does uppercase b also get corrupted? Let's see. Nah. Okay, so uppercase b survives. So the bad characters are the lowercase variants only. And if we use them in our string, then the check bad chars function looks to be corrupting them. Alrighty, so what are we doing with this binary? We've got a function called useful function. Sounds useful. Which is systeming the ls command. Interesting choice. What does this challenge want us to do? Does this challenge want us to shell it? Or just get a file listing? Because it did ship with a flag, but this command is not going to divulge that flag to us. I don't want to read that challenge briefing in case there's spoilers in it. If someone could please check for me, for the badchars challenge of ROP Emporium, what does it want us to do? Does it want us to just execute this ls and happy days? or does it need us to get the flag, or does it expect us to shell it? That would be brilliant. Shell it. Barney, we'll start shelling things when the challenge series expects us to. We won't get ahead of ourselves just yet. At Wolf, do I need to remove F as well? Did I, Yep. I should have removed F as well. Thank you, At Wolf. I did not pay attention to what I was doing. While people check if we should be shelling this or what we should be doing, let's just try and ret to useful function. Useful function is 04. We've got a DF, we've got an 09, we've got a 40. 4009 DF. None of those are bad characters. So we should be safe to ret to useful function. That is, as long as we've got no pi. Yeah, we've got no pi, so it's not ASLR. NX is on. Oop, got a ding. Challenge page doesn't specify. I think it is to rewrite the string location. Instead of binls, maybe call cat. Yeah, the Wizzy, if we want to do that, we've actually got to do computer hacking though. We can't simply return to the function. We skipped a few challenges. Ah, did I do it in the wrong order, did I? So ret to win split is about combining elements from the ret to win challenge that have been split apart to beat this challenge. Yeah, looks like maybe I did this in the wrong order. Split should be next. Badchars looks similar to bin bash. Really? There's not enough characters there to spell bin. I see it now. Yep, I see it now. bin/bash. It looks like maybe it wants you to fix that string in memory to be... Nah, it'd need to be /bin/bash. And I don't think that's actually in a useful part of the binary. I don't think it appears in the strings. I think it appeared in the code here. Yeah, so those characters are actually contiguous in memory. Now there's our lowercase b. And then our I is 1F, so there's the B. You can see it here, there's your B, and there's your I think. Nah, I'm just making shit up, never mind. Don't mind me. Yeah, no, I don't think that's going to be a string in memory that's actually useful for us. Should have numbered them. Challenge reference is right for wrong challenge. Should we just try and do it anyway, even if it's out of order? Kind of feel like we should probably just do it now. Yeah. Irregardless, respectively, let's quickly just ret to useful function to prove the concept that we do have control over the execution flow. Buff plus equals tone.p64 pointer to useful function. Yeah, so there's our ls kicking off. So we do have control. How are we going to turn this into a shell? Let's have a look. So the string binls is in RO data. which I'm going to guess is not writable. Yeah, RO data is not writable. We don't have any writable and executable pages, as is to be expected. What strings do we have? Is there anything interesting in there? I see now where we could have maybe used this as a string, but that's again in RO data, so it's not writable. And there's spaces between the characters as well. That's not going to do us much good. So we've got a pointer to system. Or we've at least got system being used by the binary, so we can return into the, I think it's returning to PLT, which will then trampoline us across into libc's system implementation. What else do we get? We get fgets, so we can maybe ret to fgets and cause bin.sh to be written somewhere useful, followed by a ret to system to run that string as a shell command. In fact, for system, we don't need the full bin.sh. We can just write sh into memory. The tricky thing is twofold. Twofold. For the fgets, we need to fgets. Yeah, we need to find a writable page of memory. Not hard. We need to parameterize fgets, which means we actually need to do some ROPing. So again, parameterization of 64-bit function calls doesn't happen on the stack like it does in 32-bit. It happens via registers. So we actually need to start writing a ROP chain, also known as performing code reuse, to be able to populate RDI, RSI, and RDX with, I just realized something, with parameters to that fgets, and again for the call to system we need to parameterize RDI with the pointer to what we fgets into memory. Now, badchars. You know what? Badchars aren't going to hurt us because we're going to, as long as we don't use these characters in our ROP chain, which may still prove to be a pain in the butthole, we can still feed those into an invocation of fgets that we cause. So our ROP chain can't contain these bad characters. But if we manage to ROP to fgets so that we can give our own input, that input won't be subject to these bad character restrictions. So the fact that S is in here won't stop us from fgetsing sh into memory and then causing the system to go hit it up. Cool. Okay, so we know roughly how we're going to do this. I'm going to take a quick 5-minute breather. When we get back, let's see if we can manage to pull off a ROP chain that uses the fgets that the binary already has references to put sh into memory, and then system to it. We'll need to do some ROPing to populate some pointers. Sorry, to populate some registers. So I'll be back in a few minutes. Until then, I don't know, get yourself an ice cream or something. Alrighty, we are back. Hopefully you've got yourself a scrumptious treat, be it an ice cream or otherwise. So as discussed, we're going to see if we can do some ROPing while avoiding some bad characters, to call fgets, to write the string sh into memory, and then use ROP again to populate some registers, and then return to system. So first of all, where are we going to write this? Normally I target BSS, just out of habit. BSS looks like it smashes straight into extern. I don't know if we're allowed to really be smashing this stuff, so I'm not gonna be writing to BSS in case it causes instability. What else is writable? .data is writable. Do we have like the end of a page somewhere that we can... Let's go check VM map. So my process got replaced by ls, which is not the VM map I'm looking for. That's going to give us a crash. This is some padding. Let's crash this sucker. VM map. So where can we write to that has a consistent pointer? So 601.000 to 602.000 is readable, writable. The heap is going to move around due to my system's ASLR. So somewhere in this page here is where we're going to do the write to. So at the end of BSS, does that actually smash into extern? A0, 601, 089, 601, OBO. They do smash together, don't they? Extern's full of question marks. Maybe extern. Yeah, okay, extern must be writable. I'm showing a lack of knowledge here. But look, extern finishes at 601.178. So at 602.000 we can write, but OX20 is a bad character, so 601.300. No, 601. 601200. Those are legal, they're not bad characters. So 601.200 is where we'll write to. So we'll go pointer to our string. Is that OX 601.200? Is that right? 601.200? Yep, we can write there safely. And just to make sure, 601.200 is mapped as read-write. So we can write there safely. So the point of our string is 601.200. We need to find ourselves some ROP gadgets. Let's run opt ropper ropper.py against badchars 64. We need to go -f badchars 64. And here we got a bunch of gadgets. So if you're not aware, ROP can be a bit tricky to kind of get yourself used to. It's a type of code reuse. So what we do is we run a program such as ropper.py, which will parse all the executable sections of our binary and find all the executable sequences of bytes that end in a ret or something similar. Call racks, it also kind of looks for stuff that ends in call register or jump register. And basically then kind of walks backwards from that ret or that call or that jump and kind of digs up anything that looks like it might be vaguely useful as a small sequence of instructions, which we then have to kind of glue together into what's called a ROP chain. Individually, these are ROP gadgets. You glue them together into a ROP chain. One of the reasons why ROP is so usable on Intel is because Intel is a variable instruction length I swear there's a more technical term for that, but I'm going to call it a variable instruction length architecture. Meaning, because on some architectures, right, whether you're adding to a register or subtracting to a register or moving one register to another or moving a value, like an immediate value, into a register, all the instructions, the opcode and the operand or operands, I believe as an entirety, they're of constant length. Not the case on Intel, which can mean that disassembling from any random ass point in memory often won't result in any intelligent series of instructions, because instructions can be of all sorts of different length. You know, this instruction might be a NOP, OX 90. 90's NOP is. I haven't done binaries for so long. You know, NOP is a single byte instruction, whereas, you know, adding, incrementing a register, I think might be a single byte instruction as well. But, you know, moving an immediate value into a register is a much longer instruction. So basically, by the fact that instructions can be of variable length, then, you know, at 1 byte off of any given gadget, there can be a completely different chain, a completely different gadget arise due to the ambiguity of where you start reading in memory. So all these here aren't kind of naturally occurring necessarily inside of our executable section of our binary. ROP gadget finders can be incredibly creative by basically starting at all sorts of weird offsets into that executable section that don't normally get hit in the natural execution of that binary. You can find some useful gadgets, which makes ROP very doable on architectures such as Intel. So we want to start picking from this list here some gadgets that look useful to us, and keeping in mind we need to be able to man fgets, because we know that fgets is a function used in our binary. We need to be able to basically load 3 parameters into registers, and those registers are RDI, RSI, and RDX. Okay. We also know that for system, we need to be able to load RDI with a value. You can pass badchars to ROP 2. Thank you, Firefart. I was, yep, thank you very much. I just wanted to kind of show the smorgasbord of gadgets we kind of start off with, and we'll refine them down shortly. But that is a great point. Thank you. We need to basically find gadgets that allow us to populate RDI, RSI, and RDX in some way. Hopefully we end up with some nice clean gadgets. So as Firefart said, if we just do ROP-H, we'll see that -b, where are you, allows you to supply bad bytes, set bytes which should not contains in gadgets. There's a pull request if someone wants to fix a typo. So we can do ROPA with the file badchars64, and the badchars being this here. Hopefully it just takes like a single string argument like this for our list of badchars. Not happy. Bad bytes has to consist of 0 to 9, A to F, A to F. What does the help say we should do? Where's our -b? Bad bytes. Set bytes which should not contains in gadgets. Whoop, we had some examples. Bad bytes. Okay, we actually need to express them as hexadecimal. Not to worry. We have those right here. We can't just drop them in as ASCII. We need to express them as hex. Which makes sense, you know. Some bad bytes aren't necessarily printable or typable characters. You may have OXFF being a bad char. Good luck actually typing that as a key on your keyboard. Alright, so let's do ROPA again with that list of bad chars right there. Looks right. Starts with 62, yep, ends with 73. Looks reasonable. Alrighty, so here is our list of legal gadgets that we can use. And again, we need to populate RDI, RSI, and RDX. So right here we can see stuff like pop RDI, ret. That is a gadget that lets us put a value on the stack that'll get popped into RDI. So that one looks handy. In fact, we'll kind of grab that now because we need to be able to populate RDI for the purposes of system. So pointer to pop RDI equals so we need RSI and RDX. Here we got pop RSI, pop R15. How do I disable the colors so I can grep? Dash no color. Grep for RSI. So here we go, pop RSI, pop R15, ret. And these all look like absolute trash. So here's our pop RSI, pop R15. Now we need to be mindful that this does a garbage pop as well into R15. I'm not going to go and reflect that in the name of the variable. We just need to be mindful that there's a garbage pop going on here. Last one is RDX. We need a pop RDX, or something that'll populate RDX for us. And we don't get one. Lovely. There's no gadgets that will let us populate RDX. We needed that for our fgets. Fgets has to have a file star. Fizzer. How do we manage to get our string into memory if we've got no RDX populating gadget? Let's have a look at the binary again. Where was the fgets actually getting done here? So we've got this instruction here, which does the move for us, but we don't really want to, ret to this gadget here. I don't think that's really going to do us too much good, because it's going to go and overwrite RDI and ESI. After loading on RDX. How can we get a string into memory? Memcopy is not going to do us too much good because we don't know where to copy sh from. Unless sh appears, I mean, memcopy is probably going to need 3 arguments anyway, isn't it? Yeah, memcopy needs n. Unless we got like sh null byte already in memory, and then we can just do a YOLO memcopy from source to dest. Now, if we got sh null byte in memory, we could just use that anyway. I wonder if sh appears in memory anyway. So let's crash this sucker. I think we can do like find. What is a string that we know appears in memory of the binary? Bin. So we can find bin in the badchars 64 section. Yeah, so that we can find bin. Or if we just look for sh in there. Not found. So there's no shits in memory. There's fine. Let us do pattern supports regex. Shit dot. No, not found. Yeah, nah, because this was finding bin, so it would have found sh followed by anything. What if we just find s? Yeah, there's a whole bunch of s's. None of these look like things that we want to system. I mean, if we're doing a local exploit, then I'd be perfectly happy to, you know, find something in memory that's, you know, a file we can drop that's executable. You know, set path. You know, drop a you know, shell called stood out. Set the path to be the directory that we have it in. Exploit the binary, and if it was a setuid binary, we could use that for a prevesc simply by systeming the stood out string. But I want to get a remote exploit sorted. Any bright ideas in chat? Would instability matter if you're going to return to bash? Yeah, Barney, so I'm guessing you're talking about when I was thinking of going creaming stuff in BSS. Yeah, I mean, it would matter if it stopped me even getting as far as bash. Mongo says X, maybe. What is X? Like an editor, and then we just like bang ID. Yeah, okay, so X will let us bang out. So we got exit. That sounds like a whole lot of nothing. We've got vi, no. Less, nap. Strings, badchars, 64. So we're finding strings of length 2, so this is probably going to be interesting enough. Is there anything, any trailing strings in here we could use as execution things? Someone shout out if you see a string in here that could be a good system victim. I mean, I'm sure there's a lot of esoteric Unix tools and stuff that we could then, for example, bang out of that I might be missing in this list. Ed? Can we bang out from Ed? Ed's not installed on my Docker container. If I don't have Ed on my machine, I'm not going to use it as a exploitation target. It might not be on enough machines in the wild for it to be a viable exploit. Worth a try. .gnu.hash. What is this sh doing right here? Hey? Why didn't, what's up, Petter? Why didn't you find that sh for me? .gnu.hash. Maybe it's part of like the ELF spec, but it doesn't actually get mapped into memory. Can we find in here? Search. Text. Hash. Alright, so I'm getting it in my strings, but it's not actually... There's like no strings in here. Oh, here they are. Yeah, maybe, you know, .gnu.hash is part of ELF, but it doesn't actually appear at runtime. Let's go minimal string length being 2 in IDA. Whole lot of nothing. Yeah. Ah, star, hey? System star. That would work if we knew PWD contained something interesting, you know, being the first alphabetical item, but that's not an assumption we want to go making. I'm guessing fgets is going to be unhappy if we don't actually set that third parameter. What if we do that ROPper again? What if we don't do our bad characters? Is there a useful gadget with a bad character in the pointer? No. How can we do this? Did I check RDX at the time of the crash? Might be something useful in it already. Great idea, Mongo. In other registers as well. Yes. Maybe you can use gets. I'd love to, but gets is not referenced by my binary. That's why I chose fgets, because it's already kind of there in the PLT and in the GOT. If I wanted to use gets, I would need to either know the victim's libc and offset a pointer that I pull out of the GOTs so that I then pivot into I can then kind of get a pointer to the victim's libc's gets. If I didn't want to have to rely on a victim having a particular libc, I would need to manufacture an arbitrary read so that I could walk through the victim's libc and find gets myself, which isn't it's not impossible. I have done that before. It's actually a really cool trick. It's one I've been using a lot lately in CTFs. In a circumstance like this, I would go down that path if I was in a CTF. I would manufacture myself a leak and basically use Pwn Tools' tooling to do the heavy lifting for me to basically go and resolve gets. I don't really want to do that for this challenge. I want to keep that trick up my sleeve for a future stream because I've got some binaries that require that, and I'd love that to be an exercise in and of itself. I don't think that's what this challenge wants me to do, so I'm very keen to learn what it wants me to do and find what that is. But good point, as to using gets, that would be a lot cleaner and a lot nicer. Meeps or check for EDX and hope the upper bytes are 0. Yeah, okay, so let's check what happens at the time of the crash. But what I want to do before I check what happens at the time of the crash is check what RDX looks like after this instruction. Because I'm not 100% sure if stood in gets set to integer 3, which is the number of the file descriptor, or if a file star looks a bit different to simply the integer file descriptor number. So I'm going to set a cheeky breakpoint here. I'm going to step through this instruction and see what we expect to need to be putting into RDX to achieve the fgets that we so desire. So I'll set a cheeky breakpoint on the RDX loading instruction, and we'll see what it looks like. Sigseg V. Why did my breakpoint not get set? Yeah. What the hell? Maybe my binary is running away on me. I mean, I'm pretty sure that usually Pwn tools will wait for GDB to attach before it, then shoves buffs down the neck of the process. But dirty hack. Let's just sleep for a second after doing our GDB attach to make sure it has time to attach. Sigseg V. Why is my breakpoint not getting set? Hey, Nutty Deo. I'm really hoping I pronounce people's names properly. Good to have you here. Finally caught the stream. Really good to have you here. Barney, not just yet, but thank you for that. I'm gonna keep on bleeding on this for a little bit longer at least. I may need a nudge shortly if things get hairy. Why is this breakpoint not getting set? Is this pointer wrong? Nope, it's the right pointer. Why are we getting to a crash? Why is my breakpoint not getting set? It's not what I asked for. Why is that breakpoint not getting hit? What if we just break on Pwn me? Derp. Oh, there we go. Yep. Did I screw that up before? Okay, yep. Cool. That was me failing to create a Python list. It was smashing two strings together and probably setting a breakpoint on the wrong pointer. That's probably what that was there. Need this little cheeky comma at the end here. Oh no, the comma was always there. Alright. All good, all good. Never mind. I don't think I did screw up. Breakpoint not getting hit. I'm too tired for this. Why is my breakpoint not getting hit? I would like a nudge if anyone knows why I'm failing to GDB on this one. GDB is probably attaching after that part of the code has been executed. Yeah, by the time this attach happens, the binary is already spun up and is waiting for my input. So I'm going to rejig my GDB foo in a way that I don't normally like to do. I normally like to start processes the natural way, but in this case, it's running away on me too quickly. I'll comment out all of that. Help of GDB. How do I execute and return a tube? Pwn.debug. Launch a GDB server with the specified command line. Launches GDB to attach to it. Returns a tube. Yeah, so gdb.debug. I can give it arguments to the process, similar to the class process. And I can give it a GDB script. Okay, this should work. T equals pwn.gdb. Was it debug? Yeah. And it'll take this argument here and this argument here. So that way, oops, we need to actually put that back. The breakpoint should be there before the process runs away on us. So I want to break on this loading of RDX. Let's try this again, hey? GDB server's not installed. Pants. Bullshit, it is inserted. Alright, this is the first time I'm getting bit for my new environment on stream. That's the second. The first one was the font size. I don't have my password manager rejigged for streaming yet. So I'm just going to go to my test pattern. I'm going to quickly go and carve this password out. Yeah, sorry, this is going to be boring while I figure this out. So I want that. Where is this password? Gee, I've missed this playlist. I should have just had it on. Reminded me of the good times. Alright. Alright, cool. I've at least recovered that one password that I need. As we were. I should make a note to put GDB server into my Docker image that I do my hacking from. I won't do that. It won't get done. I'll just install it every time I need it. Maintenance, who needs it? Yeah, we're falling down a rabbit hole here. No apologies. It's kind of like that XKCD laptop BSD. This is my life, this one. I'm just gonna go and drop it in channel. People can check it out. No, she'll be right in just showing us it. Parental's attaching too late. Yeah, it's breaking at some read, so it seems too late. Yeah, thanks Mongo. That is indeed what it was doing. You just figured it out much before me. Alright, let's try this again. Alright, we've got our break on our moving of the keyword pointer at RIP plus this address into RDX. So if we go next instruction, RDX is currently a pointer to null, ending in A8, A0. Now it's a pointer to FBAD 2088. How was I ever going to do this? How was I ever going to actually populate RDX with what it needs being stood in at glibc 225 using ROP? I don't think I was ever going to be able to manage that. Alright, are there any cheeky tricks? Exploit ROP F gets stood in. Gets stood in buffer OX100. Hold up. What is the signature for F gets? F gets takes a char star, then an integer size, and then a file star stream. So it's definitely the third argument that's supposed to be stood in. Why is that F gets signature different? Weird. What is this page telling us? That's not really what we're looking for. We're looking for F gets in the context of ROP. Maybe we're kind of dead in the water on this idea of F getsing our string into memory. No, can we like memset and like paint it in using memset? Mongo says it's a file star, it's possible but a huge pain, and you'd need controlled memory at a known location. Cool. Atwolf says we meant to learn some process from the previous challenges that you skipped. Almost certainly, Atwolf. We're currently wildly flailing and trying to cheat, which really isn't that what this is all about? Cheating flat rocks into doing things they shouldn't do. Yeah, I'd say at Wolf we probably should have learned some tricks already. Maybe next time we stream we'll actually start going through in the correct order, and when we get back to this challenge we'll go, oh, Justin was stupid. There was a real way to do it. Yeah, can we like paint with memset? It takes the size TN. Let's go back to what Mongo was saying before. Let's see what RDX. RDX is near, like null at the time of the crash. And there was no gadgets that we can use to move any other register into RDX. So I think we're basically stuck with ROPing to things that take 2 parameters or less. And I don't really want to rely on the stack unless we leak a stack pointer and use that to then defeat my system's ASLR moving the stack around. That'd be an option if we can leak a stack pointer. It's not the worst idea. RDI, RSI. RDI is 1 at the time of the crash. RSI, not a stack pointer. Do we get printf? Yeah, we get printf. If we can load up RDI with a pointer to... Again, we need a pointer to %x, 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 %x to go leak in the stack. And I don't know how to get %x, 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 %x into a part of memory that I know the address of. Maybe I'll just do this the way I was planning on doing a future stream. Maybe I'll just go to my CTF strategy, because currently I know a hammer, so I make everything look like a nail. I just need to be mindful of our badchars as I go through it. Yeah, okay. Give me a second to get spun up. This friggin' droopy ass microphone holders drooping on me. Alrighty. Yeah, okay, let's go manufacture ourselves an arbitrary memory read. Let's clean this up a bit. Let's get rid of that. That's fine. Those pointers still mean something. So we got ourselves a nice tight pop RDI ret. So puts takes a char star, right? Yeah, puts takes a char star. Puts at the PLT is this here. 4006E0, they're not bad characters, cool. Let's go and grab that pointer to puts. Pointer to puts equals OX that. Instead of our crash, we can go buff plus equals pwn.p64, pointer to puts. And then we'll point to the base of the binary. Let me just get a crash real quick. Let's examine one string. And let's see if we can find elf at this address. Yep, there it is. We've got our elf. So copy that. Pointer to binary equals that. Let's go and just puts buff plus equals pwn.p64, pointer to binary, and run this, and hopefully we get elf in stood out. Nothing. What happened there? Let's get rid of this breakpoint. Let's set a breakpoint on our crash or our ret. It's in pwn me. Point it to pwn me. Ret equals that. Let's just go and thieve it real quick. Let's break at that address. So here's our pointer to puts. Oh, sorry. I was doing 32-bit ROP. I was putting my parameter to puts on the stack. That ain't going to do us any good, is it? That's why I was getting a crash. So yeah, we don't want to just go and drop our pointer to elf on the stack. We want to go buff plus equals pwn.p64 pointer to pop RDI. So we actually go and pop this pointer into RDI and then ret to puts. So the first gadget in our chain is going to be a pointer to the pop RDI ret. It's going to pop the pointer to elf into RDI, and then it will ret to puts, and we should get elf in stood out. Yeah, there's our 7x elf. So what I've just done is a tiny ROP chain that ends in a crash, but it lets us read arbitrary bytes out of memory. In this case, let us read elf. So that's all well and good. What we want to do is we then want to loop to the top of pwn.me. So after we actually do that leak, we want to basically wrap around to the top of our vulnerable function so we can do it again. So we can leak as many strings as we want, and then once we've kind of leaked sufficient data, we then might be able to make some sense of it and dynamically create a ROP chain. So pointer to pwn.me, the function pwn.me is there. So after our puts, we want to return to buff plus equals pwn.p64 pointer to pwn.me. Alright, so that after we've done this leak, we just wrap around to the top of our vulnerable function. There it is, we get told twice in a row what the bad characters are after we've just leaked elf. And we can put some text in and we hit that breakpoint on the ret, and we get a crash anyway. Yeah, because we've gone and destroyed the alignment of the stack. And we've probably returned, yeah, to bad stuff. That crash is to be expected. But yeah, look, we can give input twice. So anyway, what we're going to do is define leak address. We're going to define a function that basically does arbitrary leaks. So instead of this pointed to the binary being what we leak what's at address and puts it, and then loop. We also need some logic in here to actually carve out what we just leaked. So we'll do t.recv until f space n space s new line. So we kind of eat everything up until this prompt here. In fact, greater than space, is that a prompt that the binary is giving us? Yes, it is. So we want to throw away everything up to and including fns new line greater than space. We want to leaked equals. I normally do a trick here. What do I normally do? I normally leak a tag. Yes, thank you for that reminder, Mongo. If I go and use this leaker function to just go and pass it to pwn.tools, it's going to try and leak stuff with my badchars. Maybe I should go ahead and reverse that badchars function so I can use my bad characters just by basically preempting their corruption. I'm going to take a quick 2-minute breather. When we get back, let's see how far we can really get. Alright, we're back. To clear my head, I took a second to have a quick look at the check badchars function, and I've got a feeling that the corruption is not avoidable. It's not like a simple XOR where we can preempt the corruption and ensure that we get corrupted to what we wanted. I believe this here, OXEB, which rings a bell as what our badchars ended up being. That literal value is being written at an address. So I think OXEB, they basically blacklist and nuke our characters from orbit with an EB, and there's no way we can preempt that action to cause something useful to happen. So like instead of our pointer pop RDI, let's just quickly hack in here, buff plus equals BB, 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 and see if it gets set to EB, 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 EB. Let's just comment that out. I just really want to induce a crash right here. Sig trap. What did I do? How did I not actually induce that crash? Oh, I'm not actually calling leak. Let's go ahead and leak one. Here's our crash. Yeah, EB, 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 EB. We can't basically undo the corruption. Our characters are simply blacklisted and written over with garbage. So yeah, we're gonna have a problem when we try and leak at a pointer that includes a bad character. Ugh. Okay, where was I? I was carving out what we actually leaked. Puts. What does puts terminate at? Null byte? Writes the string S and a trailing new line to stood out. Yeah. So we want to read up until new line and then whatever naturally happens when we loop to the top of our function. I don't think in this case we need to do my tag trick that I was thinking of. Let's go and link pointer to, is it pointer to binary? Yeah, pointer to binary is going to be our elf. So we're going to just eat up until FNS new line caret or greater than space. So here's my elf. So we want to read up until new line. Badchars are blah blah blah. And that's going to, as long as this string doesn't appear in memory preceded by a new line anywhere, I think this is a pretty safe way to reliably carve out what we leak. So leaked equals t.recv until new line paste. In fact, we don't need to do leaked equals. We can simply return that. We don't need to chop the new line off. Actually, you know what? No, yeah, we need to do leaked equals. It's going to get really messy otherwise. Let's go ahead and return leaked. Let's go and print the leak of that. I've got a breakpoint somewhere, I think. Yeah, let's get rid of this breakpoint. So yeah, at the moment our leaked return value is equal to what we want, followed by a new line that we don't want, followed by all this crap that we don't want. So let's go tag equals our tag, and then we simply t.recv until the tag, and we want to return leaked up until minus len tag. Can you do that? Is that valid Python for remove the last n bytes where n is equal to the length of tag plus a null byte, because our puts will be reading in memory up until a null byte, so we want to kind of include that in our leak. Let's see if my Python is on point. Yep, leaked hex7f elf null byte. Perfect. So we've successfully written a function that leaks bytes at an arbitrary address and then loops back up to this t.recv until fns new line greater than space is too aggressive because all I see here is a greater than space. So I want to get rid of this FNS new line, I think. Let's go and do this leak 5 times. Leaked FNS greater than space. That's not what I want. We're getting there. I just need to kind of manage my session, manage my tube a bit better. So leak is doing a send line buff and then reading until greater than space. And the first time I do it, I'm getting this crap in my leak. Why? Why am I getting that crap there? Curse the misaligned BRB, lol. Deal with it, at Wolf. Why am I getting cruffed in my very first leak? Aha! This greater than space is polluting me. What if I rec the until new line greater than space? I think that's going to ruin later leaks. Nah, that's looking pretty good. Yeah, that looks better. Okay, so I'm leaking my elf 5 times cleanly. 1, 2, 3, 4, 5. Perfect. Alright, so now we've written a function that, provided we don't use any bad chars, takes a pointer, or takes an address, leaks what is at that address in memory, and returns control to a place at which we can continue to induce the save return pointer overwrite. How do I deal with my bad chars at this stage? I mean, inside my leak here, I mean, at the very least I can just assert this is messy. This is really messy. For C in bad chars, assert C not in pwn.p64 address. How about we go pointer little endian, or pointer encoded equals pwn.p64 address. So we'll try to avoid doing that pwn.p64 too many times. Do it here too. Pointer encoded. In fact, we should do address encoded. Pointer is not address is just as useless as the word pointer, but hey, I've called leak address. I've called it address. It's too late now. Address encoded is that, and address encoded. So we should have no issues doing our leak. Yep, all good. Now, what if we try and leak BB, 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 BB. Yeah, that's what I want. Pwn.unpack64 that we should get assertions thrown, or a failing assertion. Unpack requires string. I do not count my B's. Yeah, okay, so we get an assertion error. So at the very least, at this point in time, my leak function will simply throw an exception when I try to do a leak with a bad char. It's not exactly handling it gracefully, but at least at this point in time, I know that if I start to see weird behavior, it's because I screwed something up. It's not simply because something is trying to leak something with a bad character in it. That's just a bit of a guardrail for my sanity at this point in time. It's not really fixing the problem, it's just making sure it doesn't cause me more problems. Just return none if it contains a bad character. Interesting, Firefart. This is the memleak. I haven't actually created a memleak yet. I've never actually done pwntool memleak helper classes before. I've always just defined a leak function. It's a caching and heuristic tool. See, I don't like the idea of a cache. Like, I should be at a stage where I can know what I should and shouldn't cache. but I'm scared of my leaker caching things like the stack or the heap, and not really knowing how I should express to the memleak helper class, hey, this part of memory don't do caching for. But okay, let's have a quick look. Yeah, you can see here that that's what I've created, a function that returns data as string or none. So in what cases is none allowed to be returned? When is none handled and what does it mean? Definitely can no nulls. If address and FF is 0, then return none. Else return bin shirt from that to that. Yeah, okay, maybe PwnTools, when it gets nuns out of a leaker, is smart enough to go, well, I wasn't meant to do that. Yeah, okay. What if I proceed with my original plan to lean on PwnTools' DinElf mechanics with my leaker returning none? Mongo says there's 3 characters being lost. Yeah, thanks Mongo. I think that might be simply a output encoding problem. Good pickup though. Encode as hex. I'm sure there's a nicer way to actually kind of pretty print leaked data. Yeah, there you go, Mongo. We've got our 7F, ELF, 02, 01, 01, then the null byte. So I do have my 02, 01, 01. Because I was just naively just printing in Python, it wasn't actually appearing. But yes, thank you, good pickup. I'm not going to keep on doing that encoding. For C and badchars, if C in address encoded, return none. I'm sure there's a nicer way of, a more Pythonic and a more efficient way of basically returning my none if there's a bad character in the pointer, but this will do for now. For character in badchars, if C is in address encoded, return none. Yeah, that'll do the trick for the moment. I'll learn to Python properly one day. So there's all our elfs. Happy days. If I leak an illegal pointer or pointing to any bad characters, yeah, I just get a whole bunch of nuns back. Happy days. Cool. We don't need this anymore, but I'll leave it there in case I want to play with my leaker later on. All right, let's just see if DinElf does all the heavy lifting for me at this point in time. Where's my DinElf hammer? So PwnTools' DinElf does a lot of smart stuff. It basically, given a leaker, so you have to manufacture an arbitrary memory read, basically produce that as an API for DinElf to use. DinElf then does the heavy lifting of basically walking through memory, resolving things like functions inside libc. It can also do things like resolve the stack, I think the stack base for you, and maybe even the heap base. So it can do some work that I really probably one day should sit down and look at how it does what it does, because it is hiding a lot of really smart work for us. So here we can see that the pattern is to define a leak function, and then kind of you've got to start with some pointers. At least you got to have at least one of these. Like we'll be able to get a pointer into the binary. That's easy. We then set up d equals dinelf, and you give it the leak function, and you give it any pointer that it can use as a starting point, and it can then basically do lookups for you, where it looks up things like the system function within libc. We can use this to look up gets inside libc, which we can use to paint sh into memory, which we can use to then system, and off we go. Fingers crossed it works, even though our leaker refuses to leak stuff when there's bad characters involved. I mean, this exploit might work on my box and it might not work on a given remote box, given a memory layout that is unfavorable to our weak leak primitive. But I mean, at least it might work tonight so I can go to bed. So we've got d equals pwn.dinelf leak, and we need to give it a pointer, so we'll give it the pointer to the binary instead of main, to give it kind of a starting point. And then we'll just point it to gets equals d.lookup. What does lookup need? The name of the function and the name of the library. The name of the function is gets. The name of the library is libc. And then we'll just print hex pointer to gets. And cross our fingers that PwnTools can go and resolve gets for us. Ha, crashy, and GDB crashed as well. Nice. What happened? I think this is a bug in PwnTools. I think it's choking on our none. I think it's choking on the none. Maybe we do need that. Maybe we do need Firefart's wrapper, memleak wrapper, to make sense of a none. There's a few good write-ups on writing your own dinelf type resolver. Future stream, surely. Yeah, that does sound really good. I'll have to look into that. Do I need to use memleak so that it can make sense of my giving up none responses? Yeah, I probably do. I don't know, Python, is this little @ decorator thing preceding my definition enough to have the defined function kind of inherit from this class or something? I'm not that good at the Pythons. Let's give it a go, I guess. What if we just go and drop this @ magic in front of my leak definition? Pwnlib is not defined. Do I need to go pwn.pwnlib? Yeah, no, we've still got this issue with the none type. Yeah, dinelf isn't happy with my weak leaker. Let's just kind of get an idea for what's happening. Print hex address. Yeah, so you can see that it was trying to leak something with OX20 being a bad character. You can see a whole bunch of leaks at 20. Maybe this is just like it's given up on life. Oh, thank you very much, Botter. That's really good to hear. I'm glad you enjoy it. It's just a function you can check what it does to decorate. Okay, thank you, Matt. Yeah, this yeah, Dinolf's getting real unhappy. One thing I can do is I can help Dinelf out by giving it an elf to work with. Elf equals pwn.elf, and then a string for the path to the elf. Maybe this will get us out of the woods. Maybe. What do I do? Dinelf. Elf equals pwn.elf. Elf equals pwn.elf. / badchars 64. At this point in time, I really should lift this badchars 64 string to a variable, but I ain't gonna. I mean, it got a lot further along that time. It was actually starting to look into libc, I think, before it hit the none type snag. Yeah, we can see that it got a lot further. Okay, yeah, so because I didn't have the elf for libc, I think it kind of got maybe stuck in a hole, and it kind of couldn't work its way up and out due to the weakness of my leak primitive, resulting in a pwn tools mechanic trying to use my none as an integer. I mean, we didn't do too bad. We found libc, so that's a start. But because, yeah, it got lost inside libc. What we can probably do is we can probably use dinelf to find a pointer to the stack at least. I mean, that might give us enough of a primitive. We can just go and put shit on the stack. Or if we're really lazy, we could spray shit on the stack. Or if we wanted to ensure that we were kind of not at the whims of a remote system having a different stack layout to us, we could just like spray shit for days. And use a leak of the stack base to then system our string on the stack. That might work. I mean, it's messy. That might work. So dinelf gives us a member function called stack, which finds a pointer to the stack via environment, which is an exported symbol in libc, which points to the environment block. So it's still got to go off into libc to find the pointer to the stack. But hey, look, maybe it won't get quite so lost inside libc. So let's go and comment that out. Pointer to the stack equals d dot stack. Print hex pointer to the stack. That's what we get. And we get a crash. That's different. Where do we crash? It wasn't happy with this SSE magic function trying to deref racks. And racks is probably it's probably run off the end of somewhere. 70 FF. Is that inside or near to libc? Yeah. It's towards our libraries. Alright, so that didn't work either. We could leak the build ID of the remote libc, download the file, and load an elf object with the correct base address. It returns an elf object or none. Maybe leaking the build ID out of libc is enough to not get us stuck in the hole, and then maybe Pwn Tools can automatically download if it's a well-known libc. For example, in my case, it will be. It'll be a Debian packaged libc. And by loading an elf object with the correct base address, we can then resolve gets. This is a horrible rabbit hole to have fallen down. We could resolve a gets pointer inside that loaded elf, and use that to know where on the target system gets is. This will then only be an exploit that ports to victim systems that have well-known libcs. So it wouldn't work against, let's say, a Gen 2 box or some other crazy Linux that compiles everything on the fly for you. But it would work against, boxes with well-known libcs, anything with a binary package system that the sysadmin hasn't then gone and rebuilt libc on. Let's see if we can get a elf of the victim's libc. So that's not good. We won't do that anymore. Elf of libc equals d.libc. Magic did not match. And we got back a none and then a crash. That ain't good. Yeah, Mongo was right on the money. Justin's gonna get real sad when he finds out he can't leak things with bad pointers. Alright, where do we go to now? I'm almost ready for a nudge, but not yet. Unless anyone's got any clever ideas that they're not lifting out of the doco itself. That is a fantastic idea. I have actually done that in the past. Back when I think PwnTools had a bug, because PwnTools promises to do that for free. But I think there was a bug in it. So I used to do that. But in this case, where the bad character... Actually, you know what? Because often I think our bad character is at the end. Like, it tries to get these OX20s as the least significant byte a lot. So maybe it is worth doing that. The problem is, if the byte before the leak target is a null byte, it completely breaks our leaker. In which case, if we just get a single null back, maybe we do just return none and kind of fall back to our current broken behavior. But it might get us out of the woods on some of the reads at least. Reads for which the least significant byte is a bad character, and for which the byte before the leak destination is not null. Yeah, Nanny, that might actually be on the money. I like it. Let's give it a go. Oh, my leak is getting messy now. You know what? I don't want to keep printing this hex. We can turn that back on if we need it. If so address encoded equals that. If the first character of address encoded is in badchars, print least significant byte is bad. Turn this back on. Let's just try this. Let's see if that detection works. (6E) LSB is bad. 6.9 LSB is bad. 6.6 LSB is bad. Really? Okay, so 6.2, 6.3, 6.9, 6E. Yep, those are indeed bad characters. Okay, great. So I do have detection of the least significant byte being bad down pat. So if address encoded 0 is in badchars, then leaked equals leak address -1. If leaked equals a null byte, then we want to, return none, because if we've got a single null byte out of our leak at target -1, then that means this strategy is not going to work, because we can't leak the actual target if the target's preceded by a null byte. Else, happy days, we want to return leaked without the first character. So from 1 onwards. And then we do our traditional bad characters check and just, bail out with a none if the bad character's in there. I think this is going to make our leaker a little bit more robust. We should test it. What we should do. Let's get rid of our din elf stuff. Let's go back to this good old leak 5 times in a row bizzo. Let's find a pointer that has to a string that has a bad character in it. So I know 61's bad. You know what, let's just dive into the assembly. Look at something that's close to 61. So this here. Can we just copy that? Does the hex view synchronize? Yeah, it does. So at 400A61, we've got 45E5. So what if we leak? So if we leak at 60, that is supported behavior. We'll get C645. Let's just check that. My bad, I'm getting tired. Equals is what I wanted. Alright, what's your problem here? Why are we leaking the actual pointer itself? Where have I screwed this up? Get rid of this decoration real quick. Zero A. New line's a bad character, isn't it? New line is a bad character. That's what's going on there. OXOA. I was missing a bad character. Nulls are fine, but new lines are bad. I wonder if that was contributing to our problems all along. What if I just go and comment out this quick fix and let's see if that makes what we were doing before work at all, now that we've actually fleshed out our bad characters. Let's do our pointer to gets again. Need to keep that address encoded a bit there. None has no attribute in code. Let's get rid of you. D is not defined. We're getting there. We're getting to the point where we were before. There we go. So we still get none type and int. Alright, so that didn't fix the problem. Yeah, thank you, Atwolf. I did indeed forget that. I'm sure you saw it before I did. Yeah, so this 0A 60 is not going to fit the bill. Yeah, so that wasn't a sufficient fix. We'll get rid of this. Let's go back to our leaked Bizzo and change. Let's get rid of this bad character here. Change it to OB and hope that it OB 60 there is some data to leak. Okay, now let's re-enable this fixer-upper that we built a minute ago. I see why this is getting printed out. It's because we're printing pointers as debug stuff. That's not part of the leak. That's just this print here. All right, so that was probably a poor choice. We get 2 bytes of stuff leaked. Not a great test, but hopefully it'll do. So now if we bump our leak up to 61 is normally a pointer containing a bad character, right? So hopefully we get some nulls back out and it leaks successfully using our tricky little decrement hack. There we go, so we're leaking some nulls. So what we've done is mitigated part of our bad character problem. If you get the libc, you can find the bin share string that's in all of them and proceed. Yes, I can, Mongo, you're right. Good point. So thank you, Nanny. That was a really good idea. By subtracting x from it, where x is 1, we can read x bytes before the address we wanted to read from and then remove the x bytes. You didn't want to return that. Now are we going to get in like a problem where we recurse a couple layers deep? No, I think we should handle that as we pop back up the chain. I think that's going to be fine. Yeah, we've managed to mitigate part of our leak problem with by intentionally inducing an off by 1 error and then fixing that off by 1 error. What happens if we actually recurse down a few levels? And where's our print 1, print 2, print 3 ending up? Weird. I think as long as we check to see that if leaked equals null byte or none, so if leaked in null byte none, we need to bubble nuns up. I think that's going to stop us from returning bad data if we had to step back multiple increments of 1. Aren't you adding 1 byte? Getting crazy and crazy by the second. Thanks, Barney. Are we adding 1 byte, then subtracting 2 bytes when we return the string without the first character? No, I don't think we're subtracting 2 bytes, are we? Yeah, Firefart. I think it should. I think we're just basically forcing the behavior, because I don't at this point trust that Pwn Tools is actually doing it properly. I mean, we're not giving it a good tool to work with, but I think it's getting a bit lost. Like, I've seen crashes on OX. It was trying to resolve a pointer that ended in OX20 and then was trying to use none as an integer. So it was at a point where it was not willing to work with me. I think it might be a Pwn Tools bug. A character is 2 bytes. No, a character is 1 byte. A character is 1 byte. Unless ASCII characters are 1 byte. Unicode characters are crazy town. Menstrual, I highly, highly doubt it is. I highly doubt this is correct. I think as long as we check here, if leaked in null byte none, then we'll bubble nuns up and ensure that we don't recurse to a bad place. Let's just YOLO swag try our dinelf again to get gets. Here's our 1s and 2s cropping up. It was unhappy with a none that it got back. 72 BB. OX7F. Is OX7F a bad character? No, it's not. OX2F is. That was gonna suck. Why is it unhappy with this? 72, 73. I would say this last leak was preceded by a null. So we bubbled up none, and it was really unhappy to get none. I think our leak is too limited. Can we get things like the stack though? Nope. Couldn't find libc. Bullshit, you couldn't. Nah, fair enough. It's probably walking back in memory. Oh wait. 9. Yeah, it's probably walking backwards, trying to find the base of libc. Could not find the stack. Does dinelf give us anything else useful? Get right, welcome. Glad you're enjoying it. Charaxy, same to you. Welcome all, glad to have you here. This is mental. Yes, it is. I've dug myself into a really bad hole here. I'm going to take a few minutes to try and clear my head. If we can't kind of get on the right track within about 10 minutes, I think I'm going to call this stream. And I think next stream will pick up ROP Emporium in the correct order. Maybe we'll learn some tricks that they're expecting us to use for this binary. Stick around, I'll be gone for a couple of minutes to just clear my head, and yeah, let's give it like 10 more minutes and then I'm out of here. Alright, last ditch effort. If this doesn't work, if this doesn't show promise quickly, I'm out of here. This is horrible. What if we use our leak to grab the point at a system inside libc out of the processor's got, and then just walk forwards and hope to see a sh. Because I know there's a lot of sh in libc. I don't know if one will appear inside the code of system, and we may end up in a really awful place where there's a bad byte in the middle of that pointer anyway. Yeah. My brain's broken. You know what? I'm just going to call this tonight. I think next time we pick this up, we'll start at the beginning. Sorry, we'll start at the second level of ROP Emporium and work through linearly. I think we're going to learn some tricks along the way that I'm going to be bold here and say that when I find out how to solve this challenge, I'm going to kick myself a lot. I'm going to go, I should have thought of that. But at the moment, my blinders are up. I've gone down some horrible, horrible rabbit holes that have actually left my brain fried. We've been streaming for how long now? How long's this stream been going for? Like 3 hours. I'm destroyed. So thank you for sticking with me tonight. I'm sorry we didn't end up shelling this one. I'm sure we will at some point in the future once we kind of go through this in the correct order. But for now, I'm going to head off and lick my wounds on being destroyed by this. So thank you everyone. Before you go, I want to say a big thanks for making these streams and videos. It's been a massive help. Oh, thank you so much, Simon. Really appreciate it. Thank you, Mongo. Look, I hope to be back sometime relatively soon. The next few weeks of work, I know, are going to be kind of crazy for me. I've got a lot going on at work. Tonight was just a kind of an opportunity I wanted to take to kind of, I don't know, turn the tap on. It's like those things like when you sit down to do some work. It kind of helps to get started. Until you get started on trying to achieve something, it seems insurmountable, and often starting's kind of the hardest part. So I wanted to do a stream tonight to kind of be like, hey, I'm back. I've demonstrated to myself that my environment works. I've demonstrated that I still enjoy this. You people seem to enjoy it, based on kind of sticking around for 3 hours of your precious Saturday nights, or wherever you are in the world, whichever time or whichever day it is. So no commitments, no promises as to when the next one's going to be. No promises that it's going to be catch you tomorrow. Yeah. Oh, Menz, you actually will catch me tomorrow. I thought that was a joke, being like, oh lol, you're going to stream tomorrow. But yeah, Menz, I'm looking forward to catching up with you while you're in town. But for everyone else, I will see you sometime soon. Hopefully it's not too far in the future. But yes, thank you so much for sticking around tonight. I've greatly appreciated your company. I will see you next time.